Hello and welcome. My name is Subhasis. In today's session on DataBricks Chapter 5, we will do the analysis of different Databricks clusters, the SKU types, VM SKU types, which are being consumed through those clusters, and how many jobs have been allocated to different SKU types, how long those jobs have used against those SKU types, and the cost analysis for each of those SKUs, right? So it will be primarily useful for doing cost analysis and infra sizing analysis as well. Okay, so let's go and look at the changes for today. We are on chapter 5, the readme. Just refresh. The objectives today's session is jobs run history. Look at different jobs run history, run time, how long they have run, and then SKU based cost analysis and also sizing analysis, right? In terms of steps, this is the additional step for chapter 5. Apart from that, we have already run till chapter 5, all these steps till here. Okay, and then the number, the Python files that will be running are not going to change, right? However, you might see some improvement in the code for jobs run and possibly in cluster events. That's it. So let's look at some of those changes and then we'll quickly jump onto uh, the analysis part of it. In jobs run, okay, jobs run, what changes you'll see is, so now let me take you to the part where actually the code is starting to run. So instead of getting a job list, I'm getting a list of job runs. That is one change. And then I'll navigate through only the job runs list, not really job list. Okay. And then so in, let's say, some of the clusters, ephemeral clusters, job clusters, which are used only during the course of that particular job run. So that cluster instance would be coming only once. Right? It is not a repeated cluster that pre-exists and you are reusing that. It's not that case, right? So every time you run the job, it will bring up a new cluster. So what I'm doing here is I will check. Uh, First of all, let's quickly look at check if it is a valid run. Now, let's say in a multi-tenant scenario, right? You might be having one cluster, one database workspace, and then in that you are running jobs for multiple tenants, right? Uh, so, and then each of the tenant, when you invoke a job, you might be having some specific tag so that you can differentiate, like for which market or which tenant the job is running. So for that, I first checked, a tenant pattern for you. Pick the tenant pattern that is suitable for your scenario. In my case, it could be some country code, right? That we use for invoking each of our jobs, right? And in that situation, I'm using that as a pattern. Now, in your situation, if there is no tenant pattern, just keep it empty, right? Or none. If it is none, then you don't really bother to filter out anything, right? So you look at all the jobs which are running against that workspace, database workspace. For me, it's little specialized, and because it might be useful for your scenario as well, so I put that tenant pattern. All right, so that will check the first thing. Second thing is, if it is a valid run, it will get into upstart cluster info. So it will detect the cluster ID against this job, and if that cluster ID does not exist in my database cluster table, it will then insert. Okay, it will insert with those cluster information in database clusters. First thing. Second thing is, so that's one thing, upstart cluster info. It will do the same thing for job table as well, exactly the similar pattern. So it will first check in the job table. If that job does not exist, in that case, it will insert a record in the job table. Right? Those are the initial few changes that we have introduced in chapter 5. Here I'm actually inserting the database jobs run. Okay, and then at the end, you'll also see, this should also add into cluster events table. So for this particular cluster ID at this timestamp and the event number, if there is no record, then it will insert the recording cluster events table. Those are some of the changes that you will see in this chapter, right? Other than that, rest of the things are fine. Okay. In interest of time, let's move on to the analysis part, right? So I'll quickly, in the background, I'll quickly run these files and keep the tables ready. Okay. Okay. So before I pause the video, I have run a couple of files as mentioned in the objectives, not the steps, right? Clusters, jobs run, and cluster events. Okay, these four files have run. So all my tables are ready and populated with the data. There is one more table that I have introduced in this chapter is DataBricks cost analysis. You can see a job run name for which run of the job, node type ID, this is queue type, and job start time, at what time the job started. That is my composite primary key, and few other information I will explain when I actually come to that step. The next thing is, okay, let's go to superset and create the database connection for this new database. In this case, it is chapter 5. So you can see that as well here. I've created a new database for this chapter. Okay. Okay. So I'm ready. Now if I refresh my page, I'll probably see that database listed here. Yep. And then chapter 5 is the scheme. It's a sample run. I can pick some queries from my dashboards.sql, and simple one first. I'm sure you have already run these queries in the previous chapters, so I need not explain much here. Just to join between cluster and the jobs table, so that I can show you the details for each of the job, each and which cluster and cluster specific details like cluster name, kind of cluster, auto termination, all those details I can show. Okay, that is my first query. I can save it, cloud info SQL, and then I can take that chapter 5. Okay, that's first. Next one would be the actual analysis for today. Let's jump onto that. So in this, if you scroll towards the bottom, you'll see I've kept 15-minute aggregation analysis. This is where I'll take a little time today. So let's copy this and then I'll explain it. And it would be until here. The table is already created. When I run the tables.py, it has already created that table. Let's refresh that in MySQL. And you can see the new table, cost analysis. You can see the schema also if you want. Job run name, node type ID, start time, date, difference. This two I'll explain. Now, okay, so there is bit of advanced SQL. First thing is I'm getting the minimum time from database jobs run. So that table records all the jobs and the run history. And I'm getting the minimum time. That means the earliest job that ran in this particular workspace for a particular tenant, right? I'm analyzing with tenant filter. So in your case, if there is no tenant, forget about it. Just for that whole Databricks workspace, all the jobs that you ran, what was the earliest job that was run? Same thing, the reverse of it, right? What is the job that has run the last, right? Uh, yeah. So that would be pretty close to your current time. If I run after some time, you'll see that, because I've just collected the data a few minutes back, right? Few seconds back. So you will see very current time on the job end date time variable here. The interval minutes is 15. So what this means is, let's say your jobs are running, multiple jobs are running every few second minutes, right? Now for doing the cluster sizing analysis, what I'm doing is I'm aggregating the data of the job run to their nearest 15 minutes. So if let's say 10 colon 02, that means 2 minutes first after 10 o'clock. If there was a job that was run, that will be rounded off to 10:15. So the next, 15th minute or 30th minute or 45th minute or 0th minute, right? The next. So let's run only this two part, then it will be easy for me to explain the output. So what is this doing? So I'm doing this 15 minutes aggregation here. You'll see that. Yes. J or job run dot job run name. C is cluster table dot node type ID, that is the SKU type. Job start time in date time format, that is coming from jobs run table. Apart from that, what I'm doing is using this MySQL. So I've used MySQL specific uh, function here, timestamp difference in minute between these two, right? Begin date time is what I'm taking, that minimum of the date. So the earliest date on which any job ran and the zeroth uh, hour of that, right? Okay. Yeah. So yeah, so you can see the value of this is 10th of August 2022. So if you have run job earlier than that, you will get date earlier to this. If you have run job after this, you will get according to that. So there is no time part here, right? And then end date time, if you see, that is uh, this, like 9th of October, yeah, today, and then sometime back. So this has the time part as well. The first one does not have. So begin date time and then job start time dating. That's basically for each of the job run. You will have this job start time dating. So I'll take the difference in minutes, and then what I'm doing this uh, ceiling function again, timestamp difference. This divided by interval minutes. So divided by 15, okay, into again interval minutes. So you'll see when I'll show you the value that will be rounded up to a multiple of 15. This one, right? Not the first one, right? This is absolute difference. This is the difference, and then multiple. It's a multiple of 15, right? So if let's say this is 602, then it will be probably 615. Right? Date add, yeah, that is like what is the next 15-minute interval from the job stack time date based on this rounded difference on the. Okay, let's see the value of this. Wait, yeah, it's ordered by, I'm assuming, ordered by job start time date, so it's easy to read that way. So this was the first job, smart forecast something. um, so yeah, please don't have to look at these names as such. Okay, I should probably run it one more time. So job, that job ran at 10 to 28, and then it was rounded off to 10:15, and then the difference is from, as you might have heard, like begin date time is at 10th. Sorry, this particular day, right? 10th of August, and then 0th hour. So from 0th hour till 10 o'clock, 2 minutes past 10 o'clock, it is about 602 minutes. You can do that math, right? 10 into 60, 600 plus 2, 602. and then the nearest 15th one is 6:15, and based on that the time, timestamp nearest 15th timestamp is 10:15. Rest of the data is coming from the existing tables, right? Max workers, and so on and so forth. So likewise, it will do for all these jobs. Now, then what am I doing the next? So you understand this inner table now. Here, this we have explained. Now we'll be doing some aggregation, right? So what it will do, node type, based on node type, job start. So every 15th interval, right? So now node type and this. So 10, 15, let's say there is one, but at some time point we'll see 10, 16, 15, there are multiple records because your scheme types are different. Now what we'll do, uh, for every node type ID and particular interval, we will do some more aggregations like max of max workers, sum of max workers, total workers, and average. So we'll take max, sum, and average. Why it is important is, let's say multiple jobs are running, or we in that 15th minute interval using same SKU type. However, each of them might have a different, because they're running in their respective clusters. So each of the jobs might be using a cluster, and that cluster has a different max worker defined, right? So in that 15th minute, for that SKU type, what was the max worker, irrespective of how many jobs are running against that SKU type? And then across all the jobs which are running in that 15th minute for a particular SKU type, what is the total workers, and then average, right? If I'm running three jobs altogether, let's say I have used 30 from three different clusters, uh, right? It could be like 1, 5, and then 24, right? Three different clusters, but your average becomes total by 3, right? So that's the math that we are doing here. And the last one is, um, some more aggregation here. That is like, okay, for that SKU type, across all the time points, what was the max of max workers used? And then what was the max of average workers? And what is the max of total workers, right? Now, this is primarily useful for your sizing, infra sizing, right? For that SKU type, if you move from one environment to another, for some reason, right? You want to see, uh, for this particular tenant, what would be the parallel infra size that would be required, right? Because what I mentioned, like, in a single workspace, database workspace, if you're running from jobs from multiple tenants, doing this level of segregation, you might have a view of what is the infra across all tenants that is allocated. But if you want to see tenant-wise infra, then this is the kind of analysis that you have to do. And in the final state, uh, the table that I mentioned earlier, which is this one, DataBricks cost analysis. In this, I'm going to insert some of these raw records so that, this is more of an aggregated data, right? But if you have that data at a granular level, then you might be able to pivot that data the way you want and can do some more different kind of analysis. So for that, I have given you, inserting the raw records, which is from this particular step. So selecting all this and then inserting into a table. That's the final step. So let's run the complete SQL here. Oops, did I miss something? Let me duplicate. Why did I already run this? No, I did not. Where is the duplicate? Oh, zero records written. Now that is from this query. Duplicate entry. Let me quickly check that. Oh, I should have selected a scratch file. That's fine. It's a simple text. Oh my god, why I'm taking so long? Just duplicate entry for show and show. Okay, I have done some analysis like, as to why that error was coming, and I realized there is no error as such. Um, However, one thing that I have to use was setting the database context, right? Use Cloud InfraDB is 5 as the context, and rest of the query you can run. Okay? There's no issue. So let's see if my table has got data populated into it or not. Okay. Let's run that one more time. This query is not getting any record. Why? It would be so. Let's see that. Oh, there you go. This is something I miss every time. So unless you insert the SKU price, some of the query will fail there, right? So uh, yeah, this is the one that we insert into cloud infra, right? Now I should be able to run it, hopefully. Yep, there you go. This is one query that I wanted to show you. I'll explain that further. The other part is, okay, so we have run till here. SKU-wise usage and cost, SKU-wise sizing, right? So let's run this. So now we have got the data here. Close this. What I'm doing, select star from DataBricks cost analysis, which is this table that we just generated. And then I'm doing some aggregation. Now it's similar to what we have already done here. It just this particular query, if you see the last query here. So this inner query is your now DataBricks cost analysis table. On top of that, we are doing some analysis that I have already explained. Okay. If you run that, you'll see, okay, against that SKU, what was the max of max worker, what is the max of average worker, and what is the max of total worker, right? Sum of all workers, right? So this will give you your infra view of how that particular SKU has been used. So let's say in that 15th minute of bucket, right? There was one 15th-minute interval where the total of 147, this particular node type or SKU type was used. Nodes, 147 nodes were used. 64 nodes of this SKU was used, and 64 nodes of this SKU was used, the maximum. So this will give you the infra sizing view, and the other one will give you the cost. We also show that quickly. The last query here, and that's where I'll stop. Today probably I'll skip creating the class dashboards. Okay, not required for today. So what this is doing is for every job that you run that is recorded in jobs run table, you have the setup duration and execution duration. So setup duration is probably how long it takes to bring up the cluster, the initial running state, and then the actual execution starts. This is the duration that the job has taken to actually run the code, right? Simple one. Sum of this divided divide by date div your recent time and the initial time. So basically, assuming this particular job, I'm assuming this particular job is running every day, right? All the jobs I'm assuming that way. In some, some cases, your jobs might be running couple of times a day, couple of times in a week, right? Or weekly once, right? Or monthly once. So based on that, I know that's fine. But if assuming this job might be contributing some runtime or cost every day, uh, that is the calculation I've done. Right? How much totally it has done, how long this particular job, and then divide by the difference in date, right? So at a day level, that way you get the average of daily runtime in minutes, and then this one is max of workers, the cost part, right? How many max workers, how many workers that cluster is using, how long, sorry, what is the hourly price for that particular SKU type per, I think this is per hour, right? So I'll have to do some adjustment here. I'll have to divide this by 60. That's one thing I'll do that. Actually, let me do that myself so that we don't mess it up. Because the cost is at an hourly level, right? So you have to divide that because your time is in minutes. Any other place, if I have that also, I have to divide by 60. That should be the right view of it. Let me run it one more time here. Okay, very good. So then the next one is sum of the job. So this is basically total runtime in minutes, not the per day. And then this one is setup duration. This is average, right? So average runtime minutes. Uh, every time the job runs, normally for how long that particular job runs. These are very, very useful metrics. Like you get it at the skill level, you get it at job level, right? So you get, how long normally the job runs, and then you can get the max also, you can get the min also. So if you plot them, you'll see at a job level also, the fluctuation in terms of the runtime, and then accordingly the cost will also fluctuate, right? The longer it run, the more it will cost you. So you can look at these metrics, and then further you can aggregate at a, this is easy now, right? To aggregate at a SKU level, SKU type level, right? That you can do easily now. Yeah, do that and finish. So you want node type ID, that is your SKU type, comma, sum of, and just do, cost for now. Just do the cost, because in the other query probably got that, the emphasizing. This will be your cost view of it, right? So I'll say what was my cost here, total cost. This is the group by your node type ID. Select node type ID, comma, oh sorry, my bad. And then every time you do, probably it would require an alias, so just give it an alias. This is what cost view, jobs cost, just give it a name. That's it, right? So at a SKU level, you can get the cost view, you can get the total runtime, for how long that SKU has been used, all those details also you can get. Okay. So hope you like this video. Please put your comments in case you have some feedback. Thank you.